So in this class, we will be discussing about limiting depth of a neutral axis of RCC section in Flexure. So let us assume a beam which is subjected to external loading. So due to this external load, it will bend like this or it will sag like this. The deflected shape of the beam will be so it will look like this. If this is your neutral axis, so top fibers are subjected to compression, whereas your bottom fibers which are subjected to tension, right? So I have taken the same cross section of the beam. So here width of the beam is B, whereas overall depth, so overall depth of the beam will be D, and its effective depth, so its effective depth will be small d. Okay. So if you have a strain distribution diagram, so it will be like this. The strain distribution diagram will be linear. So this is compressive strain, and this is your tensile strain. So this is your neutral axis. So neutral axis is an imaginary line which divides the area of compressive strain and tensile strain. Clear? So this depth of neutral axis, it is XU limit or XU max. So here both are same. XU limit, limiting depth of neutral axis, or XU max, maximum depth of neutral axis. Both are same. So remaining depth, it can be written as D minus XU limit. Clear? So this is your triangle A, B, C, and this is your triangle B, D, E. So if you refer clause 38 of IS 456 2000, that is on page number 69. So let me open the code. So IS 456 page number 69. See here in page number 69, you have a assumptions for limit state of collapse in Flexure. So out of which one of the assumption is the maximum strain in concrete at the outermost compression fiber is taken as 0.0035 in bending. So this maximum strain in compression, maximum strain in concrete at the outermost compression fiber is taken as, so this can be taken as 0.0035. So our next assumption will be the maximum strain in the tension reinforcement in the section at the failure shall not be less than, so Fy divided by 1.15 ES plus 0.02. So here Fy is characteristic strength of steel and ES is modulus of elasticity of steel. So now strain in steel. So it can be taken as Fy divided by 1.15 ES plus 0.002. So see here, 1 divided by 1.15. So 1 divided by 1.15. It can be 0.87. So this also can be written as 0.87 Fy divided by ES plus 0.002. So this is maximum strain in the tension reinforcement. So in tensile strain, it can be written as, so 0.002 plus 0.87 Fy divided by ES. So this is tensile strain. Clear? So if you observe these two triangles, so one is triangle ABC and triangle EBD are similar triangles. So these two are similar triangles. So this is triangle ABC. So this triangle is triangle ABC, and this one, this triangle, it is triangle EBD, are similar triangles. So from the similar triangles, it can be written as AC divided by AB. So this is your AC for triangle ABC. So this is base. So height of the triangle will be AB, which is equal to, so triangle in EDB. So this is ED divided by BE. So this is ED and this height is BE. So this is base and this is height. So from the above diagram, AC can be written as 0.0035 divided by AB can be written as XU limit equals ED can be written as 0.002 plus 0.87 Fy divided by ES divided by, so BE can be written as D minus XU limit. So it can be simplified as, so I will take this D minus XU limit here, and I will take this 0.0035 this side. So D minus XU limit divided by XU limit equals 0.002 plus 0.87 Fy divided by ES. So all divided by 0.0035. So here on left hand side it is D divided by XU limit minus XU limit divided by XU limit equals 0.002 plus 0.87 Fy divided by ES. Sorry, this also written as, so this can also be written as 0.002 ES plus 0.87 Fy divided by 0.0035 ES. So here XU limit divided by XU limit, so it will be 1. Okay, so D divided by XU limit equals, so 0.002 ES plus 0.87 Fy divided by 0.0035 ES. Here it is minus 1 on left hand side, it is minus 1, so then it will become plus 1. So D divided by XU limit equals 0.002 ES plus 0.87 Fy plus 0.0035 ES. So divided by, in denominator, so you have 0.0035 ES. So I will add these two terms. So 0.002 plus 0.0035. So it will be 0.0055. So in this equation, so 0.0055 into ES plus 0.87 Fy divided by 0.0035 into ES. On left hand side, you have same D divided by XU limit. So if you refer IS 456 2000, page number 15, so that is clause 5.6.3, you have a ES value, that is Young's modulus of steel. It has to be taken as 200 kilonewton per millimeter square. So Young's modulus of steel, which is equal to, so I will convert this kilonewton per mm square to Newton per mm square. So 200 into 10 power 3. So it can also be written as Young's modulus of steel. So 2 into 10 power 5 Newton per millimeter square. So I will substitute this value here. I will substitute Young's modulus of steel in the above equation. So now it is D divided by XU limit equals 0.0055, it is 0.0055. So into ES, 2 into 10 power 5 plus 0.87 Fy divided by 0.0035 into 2 into 10 power 5. So let me simplify first this term. So 0.0055 multiplied by 2 into 10 power 5. So you will get this value as 1100, 1100. Next, simplify these two terms. So it is 0.0035 multiplied by 2 into 10 power 5. So it is 700. So D divided by XU limit equals, so 1100 plus 0.87 Fy divided by 700. So let me reverse it. So let me reverse this equation. So it will be XU limit divided by D equals 700 divided by 1100 plus 0.87 Fy. So final equation will be XU limit equals 700 divided by 1100 plus 0.87 Fy. So multiplied by D. So this is the equation for maximum depth of neutral axis or limiting depth of neutral axis. So if you remember this equation, you can evaluate the maximum depth of neutral axis for various grades of steel. So equation is, so XU limit equals 700 divided by 1100 plus 0.87 Fy multiplied by D. So let me call this as equation number 1. So first let me calculate it for Fe 250 for mild steel. So for mild steel, Fy will be 250 Newton per mm square. So XU limit equals 700 divided by 1100 plus 0.87 multiplied by, so Fy will be 250 multiplied by D. So if you simplify this, you will get value as 0.531. So XU limit equals 0.53 times D. So this is for Fe 250 for mild steel. Similarly for Fe 415. So 415. So Fy will be 415 Newton per mm square. So depth of neutral axis XU limit equals, so 700 divided by 1100 plus 0.87 into 415, so multiplied by D. Again, if you simplify this term, you will get it as 0.479. So 0.479. So final equation will be XU limit equals 0.4848 times D. So this is for Fe 415 grade. So similarly, you can calculate it for Fe 500 also. So for 500, grade, Fy will be 500 Newton per millimeter square. So XU limit equals 700 divided by 1100 plus 0.87 into 500 multiplied by D. So if you simplify this term, you will get 0.456. So final expression will be XU limit equals 0.46 times D. So this is for Fe 500 grade. So similarly for Fe 550, so its yield strength will be 550 Newton per millimeter square. So I will directly write the equation. XU limit equals 0.44 times D. Similarly for Fe 600, so its yield strength or characteristics, tensile strength will be 600 Newton per millimeter square. So final equation, maximum depth of neutral axis XU limit equals 0.43 times D. So this is for Fe 550 and this is for Fe 600. So let me list all the equations. So first equation is for Fe 415. So for Fe 415, sorry, first equation is Fe 250. For Fe 250, so XU limit will be 0.53 times D. For Fe 415, XU limit equals 0.48 times D. For Fe 500, so XU limit will be 0.46 times D. For Fe 550, so maximum depth of neutral axis is 0.44 times D. For Fe 600, XU limit will be 0.43 times D. So these three equations are available in your IS code. So if you refer IS code, IS 456 2000, page number 70, or you can refer table B, page number 9 of SP 16. You have three equations for 250, 415, 500. Okay, so let me check the code. Page number 70 in IS 456 and page number 9. So go to page number 70. See, you have various grades of steel and XU max by D values. For 250 it is 0.53, for 415 it is 0.48, for 500 it is 0.46. So similarly check SP 16. So in SP 16 page number 9. So page number 9. See here, table B. For 250 it is 0.531, for 415 0.479, for 500 it is 0.456. In addition to that, we have evaluated the maximum depth of neutral axis for 550 and 600 grade also.